Hey, hello everyone. So today we'll be solving a new problem that's called maximum candies allocated to K children. So what this question states is that we have given two things. The first thing is that we have given a candies array of candies. The next thing that we have given is that the K. So what this K is the number of children that we can have. So we have three children for now. So for there is one more condition for these candies. So five, for example, this candy to be five is 5, 8, and 6. So these candies can be divided into like whatever we want in chunks, multiple chunks. That can this 5, for example, it can be divided into 4, comma 1. Is this valid? Yes, it is. And it can also be divided into, for example, 3, comma 2. Is this valid? Yes, it is. And also other things like 1 comma 1, 3 comma 1 comma 1, for example, like that. So these 5 or 8 or 6, each of the candies can be divided into these chunks, these small chunks. So this is the condition that is given to us in the question. So these are the two informations that we have given. So what we have to give as an output for the question to get accepted is that, so for each children we want the maximum candy. Listen to it clearly. So for each children, for example, as we can see in this one, so the maximum would be 5. So for each children we will be having 5, 5, 5, and 5. How? Because this 5, it can be divided into 5 comma 0, or if you don't divide, that's also fine. So this way, this is the 5 that we get for the 0th or the first kid children. And for the 8, it can also be divided into 5 comma 3. Is this valid? Yes, it is. So that way we get the second one. And this 6 can also be divided into 5 comma 1. Can it be divided? Yes, it can. So that way we get this values as 5, 5, 5. So for each children, we get the value as 5, 5, 5. That was the maximum one. Okay. So there's also one more condition, that is what it will happen if we have the children that is greater than the number of candies. So the maximum candies that we can get would be 5 plus 2. 5 plus 2 would be 7, right? So the maximum candies we have is 7. So this 7 cannot be distributed to 11 children, right? There is no way we can do that because this 2, if we maximum arrange it as 1 comma 1, then also it will be 2. This 5, it will also be maximum ways it can get is 5. So 5 plus 2, 7. So there's no way that we can distribute 7 candies to 11 children. So sorry for that. So we have to return as 0. So sadly, we have to return 0. So this is the base condition for that. So let's dive into the intuition and the solution for that. So let's dive into the intuition part. So as you can see, we have to divide each array element into different chunks. So the brute force way would be to start from, suppose, for example, we can get this 3 elements. So the maximum was, I think, 19, right? So this 19, if we divide fairly with each children, it would be 3, right? So the calculation would be 19 by 3 would be 6, right? So the maximum candy, if the worst case would be, or the best case would be 6, right? So we can get that, okay. So we have to check from 1 to 2 to 6. So we can run a for loop which will check for each array index. Suppose this one, we will check for each array index that, okay, what is the value? Or 1, can it be divided? Yes, it can. Okay. Can it be divided? Yes, it can. 6 can be divided into 1? Yes, it can. like 5 comma 1 that we have already seen, right? Okay. So now we have 1 as a candidate for the answer. Okay. We'll store it somewhere here. When can we do that? Now for 2, we can check. Okay. 2 can be divided into 5. 5 can be divided into 2. Let's see. 3 comma 2. Yes, it can. 8. Yes, it can too. 6. Yes, it can. 4 comma 2. Right. Let's move on to 3. It will be same. 3, 3, 3. Yes. Let's move on to 6. Let's move on to 5. Can it be divided into? Yes. Can it be divided into? Yes. For example, 5 comma 3, it can be divided. 6, 5 comma 1, it can be divided. Let's move on to 6. So another candidate would be 5, right? The last one. After that, let's move on to 6, right? Can 6, 5 be divided by, can be divided into 6? No way. It cannot be divided. So we'll stop. So the last answer would be 5. So this would be our answer for the brute force approach. Okay. Let's start with our binary search approach. So as you have already guessed it that we will be using a binary search because we have to search for the element that can be divided for each array or candies. So we already knew that this maximum value would be 6, right? So maximum would be 6. So for the, as you, for those who don't know about the binary search, I'll quickly explain about it. And those who already know, they can just skip for a couple of seconds. So for the binary search, we have two values, two things that would be a left index and the right index. Okay. It can be also called two pointers, not the two pointers approach, but two pointers. The first, the one would be in the zeroth index, and the second would be in the last index. So last index is our 6, not 6, sorry, it's 5. Okay. Now, if we will, so what we do is that we search for the middle element in a binary search. So binary means bi means half. So we divide the array into half, right? So what we do is that how can we find the middle element? To find the middle element, we have to just add these two values and divide by 2, right? That's the basic thing. So after that, we will be getting the value as m is equals to 0 plus 5 would be 5 by 2, right? This would give us 2 because we don't take decimals. Now, moving ahead. Now, we get the value as 2, right? The middle value is 2. Okay, let's move ahead. Now, we will also have one new one that would be new pointer. That would be m is equals to, what was the value? I forgot. That was 2. Okay, so now we have all these values. So what we will do, we will check for the value in the position 2. So 0, 1, 2, this one. So for 3, right? So we'll check for 3. Can this 3 be, can divide these all the array elements? Let's check. So these 3, 5 can be divided into 3, can be 3 comma 2, right? It can be. There's also a trick to find that. So we actually don't care about the 2. We'll be getting only the maximum values is 3. This 8, I'll show you the trick. So this 8, this can also be divided into 3 comma 5. Can it be? Yes, it can be. Okay. That way we can divide it. And the 6 also can be divided into the same way. 6 can be divided into 3 comma 3, right? So that way we can get the candidate 3 that is as our answer. So our answer, the same way that we have done for the brute force approach. So 3 can be the answer, but it is not the answer, but it can be the answer, right? So the trick that I was talking about was that, so we don't have to care about dividing this. We just have to take the value 5, right? And we will just simply divide it with the value or mod it with the value. We don't actually care about the remainder. So we'll just, the value is 3, right? The current index or the mid value. So 5 divided by 3 would give us 1, right? So the answer would be 1, that we have a value. 8 mod 3 or divide in Python, it will give us the root value, like the base value, that 8 divided by 3, it will give us 2. Same way, 6 divided by 3, this would give us 2. As we know that, okay, so we can get each children a value, right? So this way we can get, okay, we have this value 3, so it is satisfying the condition. Then what we will do, so to move ahead in the binary search, we have to either increase or decrease the value of the pointers, right? So now we have so we know that, okay, this 3 is a candidate. So what we will do, we can just simply move our cursor. L would be m plus 1. Why? Because as you know, right, this 3 satisfies the condition. So we know that, okay, there can be values that can satisfy the condition, like 4 or 5 or 6, right? So that way we can change our value of L to these other elements, right? For example, suppose, let's take this example that, okay, for example, our mid was, suppose, 5, for example, okay, or 6, for example. Not the best example, but take the example, okay. So we'll see that, okay, 6 cannot divide everything. So what we will do, we will go back. So to going back, the right index would be m minus 1. Why? Because we know that, okay, if we go ahead, we won't find anything in the right side of it, right? So that's why we have to get behind it. So these are the two conditions that we will get for the binary search. We will write the code, then you will understand it very nicely, and you will like literally love it how it does the solution. Okay, so back to the question. So we had this our index made on 3. So we changed the value to L is equals to m plus 1. So what we, our m was 2. So now our m would be 2 plus 1. So 2 plus 1 would be 3, right? So our L would be on 3. So 3 would be 0, 1, 2, 3. This one. So our L is here. Our right is here. Okay. So let's again find the value of m. So we have to do the same thing, L plus m by 2. L was 3 plus 5. 3 plus 5 would be 8. 8 by 2 would give us 4, right? Let's see. So our m value is 4 now. Okay. 4 is here. Let's see. So we'll check for 5. Okay. If 5 satisfies our values, so this 5, 8, and 6 array elements. Okay. So these 5 can it be divided? Yes, it can satisfy the condition. 5, can 8 be divided into 5? Let's see. If you know the trick, 5, will it give us the value? Yes, it will give us the value 1. 6, it will give us the value 1. And this 5 mod 1, 5 is also will give us the value 1. So each index satisfies the condition, right? So we have the k for each, like for each children, we get one value. So the total would be 3. So that is equals to k, right? K is our children. So we will just simply add these 3. So the total would be, if it is greater than or equal to k, that also way we have the solution, right? That is also the candidate. So we will add this 5 into our element. So if you remember for our previous case, this one. So if we will add the total, 1 plus 2 would give us 5, right? But our k was 3. So 5 is greater than equal to k. That will also satisfy the condition, right? So that way, this was the intuition for that. Let's see. So we got the solution. So what we will do now, we will increment our L. So what our L was 3. So 3 plus 1 would be 4, right? Let's see. So 4 plus 5 would be 9 by 2 would be 9 by 2. Hmm, 4. So now the value is again 4, right? So but our pointer will shift to here. This left would be here. Okay. So now if we will check the values, we will get again 4 and then we will increase it again, right? So that way, if our L is our while condition would be like L is greater than R. So the way if or L would be in the same pointer as R, then we will just simply exit our loop. So that was the intuition for that. The reason that I showed you using this index was that because in other questions, like most other questions, you will get the array like this. So that's why I didn't show you like the one without the array. So there's so this is the approach, and you can also optimize it. Like you don't have to usually simply use this array. This was just for the better understanding. So just you can simply use the L instead of 0 or 5. You can simply use 1 and simply the values. You don't need an array for that. So how? I'll show you. So for 1, comma 2, 3, 4, 5, and 6, right? So this way, we will just do it very quickly this time, right? So L is here, R is here, and then M would be here. 1 plus 6 would be 7. 7 by 2 would be 3, right? Okay. So 3, so 3 would be here. So 3, we already know that it satisfies the condition. So what we will do? So we have M plus 1, R is equals to M minus 1, right? So so L would be somewhere here, right? So now check for this was M, okay. So now check for M again. So 4 plus 6 would be 10. 10 divided by 2 would be 5, right? Okay. So we will get the value as 5. Okay, understood? This would sound so easy now. Okay, now 5. So 5, we already know that it satisfies the condition. So what we will do, we will move our L to M plus 1. That way it would be here. Now it doesn't satisfy the condition because for our while loop, we have to get the condition as this L should be less than R, right? So, but it doesn't satisfy the condition, so we will get out of the loop. So that way you got the condition, you got the intuition right. So that way this value 5 would give us the answer, right? So let's jump on to the solution now. Let's jump to the solution now. Okay. So now we will have three things, right? So the first thing would be to get the base condition. Base condition, if you remember the base condition, right? Then we will jump on to our simply the binary search, right? And after the binary search, we had some conditions for that satisfies the children. So that satisfies. If I hope I'm right with the spelling. Okay. So this is our kind of approach. So if you remember, the base case would be if our, let's take total candies, right? The sum of candies, if that sum of candies is less than the children's, right? So suppose we have 5 candies, but we have to distribute it to 8 children. We can do that, right? So that way, we have to check if our total candies, or simply just if the value of children's are greater than children are greater than total candies, they will simply return as 0 hashtag sorry. And after that, we will continue with the binary search. So for the binary search, what we have for the values would be the maximum candies, like maximum candies would be a 0. So this is the candidate that we were talking about, the result candidate. So we just simply have to take the maximum. So that's why we'll just take the maximum candies directly, and we'll simply do our binary search. So the binary search, we have 3 things, right? The first thing is the 2 pointers that we have, the right and the left one. So the left one would start from 1, as we have discussed for that, and the right would be as the total candies that we have divided by the children. Why? We already discussed that, because the best or the worst case, the best case would be that it gets all the candies, right? So 555. So we have 15. So 555 would be distributed to 3 children. So that way we get that. So let's start with the binary search. So the binary search, the condition that we discussed was the left is less than right. Okay. Was the binary search is usually taking n log n, right? And we also have this loop inside the candies that we are also taking. So maybe n can be this also. So I don't exactly know the exact time complexity of that, but I think it can be somewhere around n log n can be this value or something like that. That was the code and the intuition for that. So if you have any suggestions or any questions, you can let me know in the comment section. Yeah. Thank you. Have a nice day.